Good evening everyone and welcome to our live coverage of another Rocket Lab Electron mission from Rocket Lab's Launch Complex 1, Mahia, New Zealand. Rocket Lab is all set to propel their PREFIRE and ICE mission into the space. Today we are on the brink of witnessing another monumental event in the realm of space exploration. We are awaiting for the 49th Electron liftoff at 3 p.m. New Zealand Standard Time for NASA's second PREFIRE launch on a mission named PREFIRE and ICE. Today's mission will launch last one of the two 6U CubeSat spacecraft in a different 525 kilometers of altitude from the previous PREFIRE launch on a near-polar sun-synchronous orbit. This launch marks Rocket Lab's amazing 49th overall launch and 7th mission of this year. Hello, my name is Dipta Maitra, performing the commentary for today's mission launch. We are super excited bringing you the coverage of Rocket Lab's PREFIRE and ICE mission, dedicated second mission launch for NASA's PREFIRE CubeSats. PREFIRE was jointly developed by NASA and University of Wisconsin-Madison and is managed by agency's Jet Propulsion Laboratory in Southern California. Now, before getting into the mission details, just a reminder, the Boeing Starliner crew flight test is aiming for June 5th at 10:52 a.m. Eastern Time, which will be 14:52 hours UTC, with backup dates on 6th. For now, weather is expected to be 90% favorable, with cumulus cloud rule being the primary concern only. June 1st launch attempt was scrubbed due to an observation of a ground launch sequencer. The system was unsuccessful in verifying the sequencer's necessary redundancy. Now just a heads up, it's just me running the show for our launches, so if we hit any technical snags, hang tight. But don't worry, I will do my best to walk you through the Electron launch happening in 25 minutes. Now let's get back to today's mission. So far, Rocket Lab reports the weather is looking good for today's Electron launch opportunity and the range is ready to support. Rocket Lab is currently targeting a liftoff time of Electron from Mahia, New Zealand at 11 p.m. Eastern Time, 8 p.m. Pacific Time on Tuesday, that is June 4th, which will be 3 p.m. New Zealand Standard Time and 3 a.m. UTC on Wednesday, that is June 5th. Firstly, we would like to thank all of you joining us for today's launch and would request that if you haven't already, please like this video to help YouTube's algorithm bring in more space fans and rocket enthusiasts. Also, it will be so kind of you subscribing to our channel. So, Electron that's supporting today's mission is an orbital class reusable 3-stage rocket which is 18 meters tall and 1.2 meters wide. An orbital launch vehicle designed specifically to place small satellites of up to 300 kilograms into the wide range of low Earth orbit. Every aspect of Electron has been designed for frequency and reliability to meet the evolving needs of government and commercial small satellite operators. Now, while the stream begins, let's learn about our own Electron in details. Electron's payload fairing protects the payload from encapsulation through flight. The fairing is 2.5 meters tall and 1.2 meters wide, and the fairing separation occurs using pneumatic unlocking using springs. It can deliver 200 kilograms to 550 kilograms on sun-synchronous orbit. Electron's payload fairing is a composite split clamshell design and includes environmental control for the payload. During separation, each half of the fairing is designed to rotate on a hinge away from the payload, resulting in a safe separation motion. Also, expanded and tailored fairing options are also available depending on customers' need. Now, Rocket Lab's Kick stage offers our customers unmatched flexibility for orbital deployment. The Kick stage is a third stage of the Electron launch vehicle used to circularize and raise orbit to deploy payloads to unique and precise orbital destinations. The Kick stage is powered by Rocket Lab's in-house designed and built Curie engine. In its simplest form, the Kick stage serves as in-space propulsion to deploy payloads to the orbit. It is most advanced configuration. The Kick stage becomes Photon, Rocket Lab's satellite bus that supports several year duration missions to low Earth orbit, mid-Earth orbit, lunar and interplanetary destinations. The Rocket Lab Kick stage is designed to deliver small satellites to precise and unique orbits, whether flying as dedicated or rideshare on Electron. The Kick stage enables missions that require deployment of payload at multiple planes, inclinations, including constellations. Higher altitude deployment, inclination out of range of the launch vehicle, hosted payload support, multiple trajectory changes, sustained low altitude orbits, and the missions which needs deorbiting. The Kick stage is a streamlined path to orbit that eliminates the added risk, complexity, and cost of having to develop own spacecraft propulsion or using a third-party space tug to deliver spacecraft to the desired orbit when flying as a rideshare. For missions that required extended payload support on orbit, or for missions exceeding 2000 kilometers to mid-Earth orbit or lunar or interplanetary destinations, Rocket Lab offered the Photon spacecraft bus, a high-performance evolution of the Kick stage. Next, we have the Electron's second stage, which consists of a single vacuum optimized Rutherford engine and linear-less common bulkhead tank for LOX, that is liquid oxygen and kerosene. With an expanded nozzle, Electron's second stage engine produces a thrust of 5,800 pounds of force and has a specific impulse of 343 seconds. The 1.2 meter second stage has approximately 2000 kg of propellant on board, and the Electron second stage has a burn time of approximately 5 minutes with a Rutherford vacuum engine as it places the kick stage into orbit. High voltage batteries provides power to the LOX and kerosene pumps for the high pressure combustion, while a pressurant system is used to provide enough pump inlet pressure to safely operate. During the second stage burn, the two high voltage batteries power electric pumps until depletion, when a third high voltage battery takes over for the remainder of the second stage burn. Upon depletion, the first two high voltage batteries are jettisoned from Electron to reduce mass and increase performance in flight. The engine thrust is directed with electromechanical thrust vector actuators in two axes. Roll control is provided via a cold gas reaction control or RCS. Still the stream hasn't been gone live, so we are discussing the Electron rocket in a little bit of details. So now we are having the first stage. The Electron's first stage consists of 9 sea-level Rutherford engines, linearless common bulkhead tanks for liquid oxygen, and rocket grade kerosene, that is RP1, and an interstage. Rocket Lab's flagship engine, the 5,600 pounds of force, that is 24 kilonewtons of force Rutherford, is an electric pumped liquid oxygen or kerosene engine specifically designed for Electron launch vehicle. Rutherford, Rutherford adopts an entirely new electrical propulsion cycle, making use of brushless DC electric motors and high performance lithium polymer batteries to drive its propellant pumps. This cuts down on much of the complex turbomachinery typically required for gas generator cycle engines, meaning that the Rutherford is simpler to build than a traditional engine but can achieve 90% efficiency. Rutherford is also the first oxygen or hydrocarbon engine to use additive manufacturing for all primary components, including the regeneratively cooled thrust chamber, injector pumps, and main propellant valves. The stage 1 and stage 2 Rutherford engines are identical, with the exception of a larger expansion ratio nozzle for stage 2 for improved performance in near vacuum conditions. This configuration, you can say, is nearly same that kind of SpaceX is having for its Merlin engines. All aspects of the Rutherford engines are completely designed in-house and are manufactured directly at Long Beach headquarters in California, USA. So the stream is not yet live. So here is a quick overview of the Electron rocket in a pictorial form. Just grab a view of this. Until that time, I will have a sip of my coffee. Now we have a request again for you. If you haven't already, consider giving this video a like, which helps YouTube's algorithm to bring in more space fans and rocket enthusiasts. And if you are feeling we are adding value to your viewing experience, please consider subscribing. We would be super grateful for your support. So now let's talk about today's payload details. Today's mission, PREFIRE and ICE, is the second of two back-to-back Electron launches for NASA's PREFIRE mission. PREFIRE stands for Polar Radiant Energy in Far Infrared Experiment. PREFIRE CubeSats is tasked with measuring heat loss from both the Arctic and Antarctica in an aim to help researchers better understand Earth's energy budget. The two 6U CubeSat spacecraft in two different 525 kilometers altitude, which will be the near polar sun synchronous orbits with an inclination of 97.5 degrees, each with a heritage miniatured IA infrared spectrometer covering the 3 to 54 micrometer of wavelength, which is also acronymed as FIR region, at approximately 0 to 84 micrometer spectral sampling, operating for about one seasonal cycle, about a year, with diurnal subsampling. As you can see, the stream has begun. So let's switch back to our stream. We will talk about the payload a little bit later in between the stream.
Hello and welcome to the launch webcast for our 49th Electron mission, set to launch from Pad B at Rocket Lab Launch Complex 1 in New Zealand in just under 19 minutes from now. Today we'll be launching the second of two launches for NASA's Climate Science PREFIRE mission after standing down a couple of days ago due to out-of-bounds LOX temperatures. Thanks for joining us. My name is Muriel Baker and I'll be taking you through today's countdown to liftoff for the PREFIRE and ICE mission, currently set for launch today at 3:15 p.m. local time or 03:15 UTC. Now, PREFIRE and ICE is the second of two back-to-back launches on Electron to deliver NASA's satellites to orbit for the PREFIRE mission. PREFIRE stands for Polar Radiant Energy in the Far Infrared Experiment, and it's a mission designed to measure heat loss from the Arctic and Antarctica to help improve climate and ice loss models that better predict Earth's ice, sea level, and weather changes. The first satellite in the PREFIRE mission was deployed by Electron to its 525-kilometre orbit 11 days ago. After today's second launch and deployment, the two PREFIRE satellites will spend the next 10 months crisscrossing Earth's coldest regions to collect their data. And once they're operating, PREFIRE will make the first full spectral measurements of far infrared radiation, revealing the full spectrum of Arctic radiant energy. Now, those measurements will then be used in climate and ice models to help better predict Earth's sea ice loss, ice sheet melt, and sea level rise. PREFIRE is focused on the Arctic and Antarctica because these polar regions have a big influence on the Earth's temperature. Excess heat escapes from there to space, and the difference between how much heat is released versus how much heat is received from the sun in the tropics is a key influence on the planet's temperature. Better understanding this process and what it means for Earth's future climate is what the PREFIRE mission is all about. Here's NASA to explain more.
The Arctic is warming 3 times faster than anywhere else on Earth.
This is a huge problem, in part because that is enhancing melt of the ice sheet. It's leading to enhanced melt of sea ice.
All of the coastal communities around the world are now seeing sea level rise around them and experiencing increased flooding.
It will impact the future generations. They're going to inherit a planet that's going to be many degrees warmer than what we are today.
We need to have better predictions of how sea level will change, how the weather around the planet is going to change. The only way we're going to do that is to understand how the polar regions are responding to climate change.
We have this considerable knowledge gap in our understanding of Arctic climate.
PREFIRE is going to fill this important gap.
PREFIRE, polar
Radiant
Energy
in the far
infrared.
experiment.
So Earth's temperature is set by a balance between the amount of energy the Earth receives from the sun and the amount of energy that it emits back to space.
Most of the energy that is radiated to space from our polar regions is far infrared energy, and we have no modern satellite observations of this incredibly important energy spectrum. PREFIRE will be deploying 2 CubeSats. Over the course of a year, they're going to be measuring the far infrared energy for the very first time that is leaving the top of our atmosphere.
Each of our PREFIRE CubeSats carry something called a thermal infrared spectrometer that looks down at the Earth and gathers energy being emitted from the planet at different wavelengths.
Just imagine a rainbow. When you see a rainbow, you see the different colors in the rainbow. And what happens is light gets dispersed. Similarly, we see the different wavelengths split up, and you can measure each of these wavelengths. And that's what the spectrometer does. It spectrally separates the radiation into different wavelengths.
These wavelengths were going to give us really important information about how the surface is changing in the polar regions, whether that's going from an ice-covered surface to a melted surface, or whether it's going from sea ice to open ocean.
The 2 satellites are going to be orbiting in a polar orbit around the Earth. The first satellite comes along and measures the scene over the poles. And then a few hours later, we have the second one come along in a different orbit and measure the same scene, so you understand the impact of how the energy changes in those few hours.
It's really important that we understand how much energy is being emitted by the polar regions, because that defines how cold the polar regions get. And that temperature difference between the warm tropics and the cold polar regions is actually what drives the entire weather system around the planet.
What we want to do with PREFIRE is we want to take these new observations that have never been made before, and we want to improve our understanding of the climate system and improve our understanding of how climate is going to be changing.
Understanding how the sea level rises and how the ice melts is going to help us understand weather events, and that's going to have direct impact on our farmers and agriculture.
There's a real urgency to getting this information now. Things are changing so quickly in the Arctic that we may only have 5 to 10 years to respond to those changes and help protect the property and lives that may be affected by that.
Launching the PREFIRE mission for NASA represents a bit of a full circle moment for Electron, because it was around this time last year that Electron launched a constellation of small satellites for NASA for a mission called TROPICS that was focused on the regions of Earth surrounding the equator, helping weather researchers understand more about the environmental factors that contribute to hurricanes there. So, from the tropics to the poles, Electron has been behind NASA's small satellite missions that teach us more about our environment and the world around us. Now, shortly, today's operators will be polled for their launch readiness in the final Go, No-Go poll run by our launch director, Yulia Wembaka. That status check begins at the T-minus 12-minute mark to liftoff and goes through each operator on console in our Mission Control Center and in our Range Control Center at the launch site. We're coming up to the poll now, set to begin in just a few seconds.
And to all operators, LDN mission code, we're proceeding now with the Go No-Go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNCs go.
Recon.
Recons go.
T1.
T1 is go.
GC.
GC is go.
Met,
Met is go.
RF,
RF is go.
copy, thank you. MM,
is go.
and LDSUP.
LDSUP is go.
The go-no-go sequence is complete. We are currently T-minus 11 minutes and 9 seconds and counting. We go for terminal count auto sequence at T-minus 10 minutes. From this time, the 3-watt hold procedure is in effect.
Greens across the board there from our launch operators during that go-no-go poll, with the team moving ahead with all remaining launch operations ahead of liftoff. Our launch time remains set for 3:15 p.m. local time or 03:15 UTC in approximately 10 minutes 39 seconds. While all eyes are on Electron's launch today from the southern hemisphere back in the United States, we have a team working steadily on a mission of another kind for our new big rocket Neutron. We have the first
Now let's continue as we are waiting for the liftoff. Let's continue talking about the payload for today's mission. So from where I was left behind, the second satellite will be deployed to the same 525-kilometer circular Earth orbit on a similar but different trajectory to the first satellite, so that both will crisscross each other every few hours near the poles. It's along these orbital paths that PREFIRE will measure the heat lost to the space from Earth's polar region in form of infrared radiation. The data will help to improve climate and ice models and provide better predictions of how the planet's sea level and weather are likely to change in future. Each satellite is fit with specifically shaped mirrors and detectors for splitting and measuring infrared light, which you just heard in a presentation from Rocket Lab some minutes before, and will mix its readings using device called a thermocouple, similar to sensors found in household thermostats. PREFIRE will supply scientists with new data on a range of climate variables, including atmospheric temperature, surface properties, water vapor, and clouds. Changes at Earth's pole can influence global weather patterns and affect sea level rise. The climate data collected by PREFIRE will help to provide a more accurate read of future of some of the Earth's coldest, most remote region, and in turn the future of our planet. Also, the payload is supplied with the canisterized satellite dispenser that both CubeSats will deploy from once in orbit. Now let's have a look at the bar graph. Before today's launch, Rocket Lab has completed 6 launches of Electron so far this year as part of its milestone. With the recent launch of the PREFIRE mission only, that was named Ready, Aim and PREFIRE back on May 25th. And now with today's launch, Rocket Lab will be having its 7th launch so far this year, and this will be the 49th Electron launch overall for Rocket Lab. Now we are currently T-minus 6.5 minutes from liftoff. As we move through the countdown, we just want to say thanks to everyone joining us live. We really appreciate you being here. Big thanks to our amazing YouTube community for being here today. And if you are feeling we are adding value to your viewing experience, consider giving this video a like, which really helps YouTube's algorithm bring in more space fans and people to find out this stream. Also consider subscribing to us as we strive hard to bring streams filled with stats and details, and we would be super grateful for your support. Now looking at the pre-launch timeline for today's mission. Starting at 7 hours, we kick off the formal countdown with a pre-launch briefing for officials. Then at 6 hours, we proceed by closing the access road to the Maitra launch site. Moving on to T-4 hours, the Electron rocket is moved into a vertical position and the loading of rocket propellant 1 begins. As we approach T-2 hours and 30 minutes, the launch pad is evacuated to ensure safety. Moving at T-2 hours, the process of loading liquid oxygen gets underway. At T-1 hour, the aviation authority is notified of the T0 target to alert pilots. At T-15 minutes, we make the critical go no go decision for the launch, which we already came across. Now at T-14 minutes and 30 seconds, the launch enable switches are set to enable. Next at T-14 minutes, the S-band communication system is set up to full RF power. At T-12 minutes, there's an optimal hold point providing a safe recycle point before we enter the terminal count. At T-12 minutes, there is at T-11 minutes and 30 seconds, we switch the range to terminal mode, and at T-11 minutes and 5 seconds, the strong back clamps begins to open. At T-10 minutes, the strong back starts retracting. All separation events are confirmed armed onboard ordnance. The stage 2 battery hot swap is ready and stage 1 batteries are enabled. Approaching at T-8 minutes and 50 seconds, the strong back retraction is complete. Then at T-6 minutes, we disable TVC battery charging and switch the flight termination system to internal power. At T-5 minutes and 30 seconds, the FTS fail-safe is enabled and the FTS status is green on internal power. At T-4 minute, AV battery charging is disabled. Coming to T-3 minutes and 30 seconds, we conduct the final range status check. At T-3 minutes, stage 3 switches to internal power and flight mode is enabled. At T-2 minutes and 30 seconds, the vehicle is declared ready and we give the go ahead for the auto sequence start. Coming up at T-2 minutes, the launch auto sequencer kicks off and it's confirmed that the Electron is on internal power. At T-1 minute and 50 seconds, ground power is disabled. Moving on at T-1 minute and 40 seconds, liquid oxygen tank pressurization begins. Then at T minus 1 minute and 10 seconds, stage 1 and stage 2 locks reach flight pressure. Moving on at T minus 1 minute and 5 seconds, fuel tank pressurization occurs. At T minus 57 seconds, the fast purge is enabled. Then at T minus 55 seconds, stage 2 fuel reaches flight pressure.
Tanks are pressed for flight.
High flow engine purge enabled.
We are T minus 20 seconds and counting.
And just let me complete. At T minus 30 seconds, the GNC initialization takes place. At T
10,
minus 20 seconds, the
9,
final engine setup
8,
is completed.
7,
Then at
6,
T minus 2
5,
seconds,
4, 3, 2, 1. Lift off.
Beginning pitch over.
and we have liftoff. The Electron has cleared the tower.
There goes our 49th Electron rocket soaring off the pad at Launch Complex 1 and on its way to space for NASA. We are now 39 seconds into the mission, and our first mission milestone is coming up, called Max Q. This is when Electron reaches the maximum amount of pressure that will work against the rocket as it powers its way through the atmosphere. We should hear a call out from Mission Control soon that Electron has made it through that structural test.
High voltage battery discharge nominal.
Cleared Max Q. That's Electron smoothly through Max Q
The
as the
Max
mission
Q call out
continues.
should be
We are
coming
now
at
at 1
T
minute
plus
and
1
18
minute
seconds
and
into
6
the mission
seconds.
as Electron passes more than 18 kilometers in altitude at more than 2,300 kilometers an hour. Up next are a familiar set of actions that Electron performs to continue the mission. The first up will be MECO, or main engine cutoff, when all 9 Rutherford engines on the first stage throttle back before shutting down. After that is stage separation, followed by the engine startup on Electron's second stage to carry onto orbit with NASA's PREFIRE satellite. Standing by now to listen out for Mission Control to check off those milestones.
Now we should get a call out for stage 1 separation from stage 2 at T plus 2 minutes and 40
Stage 1
seconds.
propulsion is holding nominal. Stand by for MECO in roughly 30 seconds.
Just 30 seconds away from the main engine cutoff. Just after
15 seconds till staging.
as you heard, we are only 15 seconds away from the stage separation.
MECO confirmed.
And
Stage
we
separation
had
confirmed.
main engine cutoff. With that, we also had stage separation. That is when the stage 1 separated from stage 2.
That was MECO, stage separation, and second stage engine start for Electron. The second stage Rutherford engine is glowing hot and bright as it carries onto an orbit, now more than 100 kilometers above Earth and moving at more than 8,000 kilometers an hour. Now, this engine is identical to the sea-level Rutherford engines used on Electron's first stage, with that exception of a larger expansion nozzle that allows for improved performance. Next up is fairing jettison of the rocket's nose cone, and the fairing is what protects the satellite on Electron through flight. But once Electron is ready to be rid of the nose cone, each half of the fairing is designed to rotate on a hinge away from the payload in a safe separation motion. And that action is due now in just a few moments, so let's listen in.
Now approximately at t plus 2 minutes and 43 seconds, the Rutherford engine on Electron stage 2 ignited, and then at t plus 4 minutes and 16 seconds, the fairing separation should occur. Following that, we should be having a call out for battery hot swap that will happen at t plus 6 minutes and 9 seconds. You can see a good nice view of fairing, and we did have the fairing separation.
And there they went. Electron's fairing halves have split and fallen away from the rocket as planned. Now that nose cone is ejected once we reach space, and we don't need its protection anymore for the NASA PREFIRE satellite that is on board. We're heading to a 525-kilometre orbit for this mission, but stage 2 will only take us to just over 200 kilometres to our perigee, where we'll separate the kick stage that has the PREFIRE satellite. So another 100 or so kilometres to go for Electron's second stage.
Now, as the fairing separation was successful, right now the NASA's PREFIRE payload is exposed to the space.
We are approaching the next mark in the launch for Electron's second stage, an action that you'll only come across with our rocket called the battery hot swap. The Rutherford rocket engine powering the second stage uses batteries as the power supply for its propellant pumps. Now, those have been running for some time now, so the battery's power levels are running low. And to prevent an engine stall, we swap out those dying batteries with a fresh pack that will keep the engine running its full duration. Now, those old battery packs are ejected once they're done, which you can sometimes see on your screen as they fall away. So watch out for those just after the T plus 6 minute mark into the mission.
So as you heard, that the next milestones we will be having is the battery hot swap.
Battery jettison confirmed.
And that is battery hot swap confirmed for the second stage Rutherford engine, called out by the operator in mission control, in which we saw on our screen just moments ago. Now, with that clean swap, the Rutherford is continuing nominally along its journey, maintaining its current trajectory towards that perigee and moving along at more than 15,000 kilometers an hour. We have a couple more minutes to go with Electron's second stage as we approach its final set of actions, with engine shutdown and stage separation expected soon after we tick over 9 minutes into the mission.
As explained, at t plus 9 minutes and 15 seconds, we should be having the second engine cutoff, that is SECO, on stage 2. Following 4 seconds later,
10 seconds into the mission, well over 17,000 kilometers an hour now, and things are looking nominal for that second stage engine burn. The next milestone for this mission will be the second engine cutoff on that second stage, which we're coming up to in just a few moments.
High voltage battery discharge holding nominal.
just after 4 seconds from the next milestone which we are looking at, that is the SECO, second engine cutoff, at t plus 9 minutes and 19 seconds, stage 2 will separate from the kick stage. And after that, as we will be nearing the end of the first phase of the mission, at t plus 51 minutes and 25 seconds, the kick stage Curie engine will be igniting.
Stage 2 propulsion is holding nominal.
Now we got a good
It's
call
now
out.
8 minutes, 16 seconds into the mission, which means we are coming up on the engine shutdown for Electron's second stage, to be followed shortly afterward by stage separation of the kick stage that is carrying NASA's PREFIRE satellite. The process is practically the same as the first stage engine shutdown and stage separation that Electron performed earlier in the launch. We'll know that it's been successful when we see that red hot engine nozzle on the screen start to turn cold with that successful engine shutdown. We're waiting though on the call out from Mission Control for confirmation of those actions.
Guidance is in terminal, 20 seconds remaining.
Now shortly after T plus 52 minutes and 14 seconds, the Curie engine will cut off. Finally, at approximately T plus 53 minutes and 4 seconds, we will have the payload deployment for PREFIRE 2 payload for NASA.
Confirmed.
We got call out for the SECO, that is second engine cutoff, being successful.
Stage 3 separation confirmed. Nominal transfer orbit achieved.
Also, we got call out for the stage 3
Successful
separation.
engine shutdown and a clean stage separation for Electron. The kick stage has been released at its perigee with its attached PREFIRE satellite ready to join the first PREFIRE satellite deployed to space just last week. Now, with the kick stage released onto an elliptical orbit first, it now has to complete its first set of maneuvers to correct to a circular orbit. This involves an engine startup in about 40 minutes once the kick stage completes its first half orbit of Earth. We'll take a break in the webcast now, but come back live for that engine startup, as well as the final milestone for this mission, payload deployment for NASA's PREFIRE satellite. We'll see you back here soon.
So now while these copyrighted musics are playing on, let's discuss about some stats about today's mission. So as we look at the mission's progress, let's look into some mission stats for today's launch. This marks the 49th overall launch for Rocket Lab, showcasing their consistent excellence in their field. It's the second PREFIRE launch of 2024 and the last one for the planned 2 launches. Now moving on to the launch frequency. This launch marks the 49th Electron launch to date and a testament to Rocket Lab's rapid advancement in technology and dedication to exploration. Also, this will be the 44th Rocket Lab's orbital launch to date. With this launch, we will witness an impressive 7th Electron launch and Rocket Lab's overall launch this year, indicating a bustling schedule that reflects the growing demand for space mission. Speaking of launch sites achievement, this will be the 19th orbital launch from Pad B of Launch Complex 1 from Maitra, New Zealand. Also, this will be the 45th overall orbital launch to date from Rocket Lab's Launch Complex 1, which is a milestone that speaks volume about the reliability and capability of the launch facilities. And let's not forget that there will be no first stage booster recovery planned for this mission, which is a strategic decision based on mission requirements. Each launch is a step forward, and Rocket Lab's PREFIRE and ICE mission is a shining example of relentless pursuit of innovation and discovery in the final frontier. Now moving on, let me walk you through the impressive overall Rocket Lab stats that underscores this launch. With the PREFIRE and ICE mission, Rocket Lab marks its 49th overall launch and Electron launch to date, a testament to their relentless pursuit of excellence and innovation. This launch is not just a number, it's a milestone that reflects the hard work and dedication of countless individuals. As we dive deep into the numbers, it's heartening to see 44 orbital launch and 1 suborbital launch success to date. Each successful mission is a beacon of hope. Yet the journey of Rocket Lab is not without its challenges. Rocket Lab has faced 4 orbital launch failures to date. But these setbacks are not defeats, they are lessons that pave the way for future triumphs. Rocket Lab has achieved 7 ocean recovery success for first stage booster to date, showcasing their commitment to reusability and sustainability. Adding to their list of achievements, Rocket Lab has successfully conducted 2 aerial capture tests of the first stage booster with recovery helicopters. And this innovative approach to recover is a glimpse into the future of spaceflight. Also, 2 successful controlled atmospheric re-entry tests were also conducted to date. And not to forget the 37 non-recovery of the first stage booster instances, which includes today's launch. Now let's have a look into the distribution of launches made by them from each pads, including today's launch. But before that, just providing a background about the Rocket Lab's launch pads. That is, Rocket Lab operates 2 launch sites comprising a total of 3 pads for Electron launch vehicle. 2 launch sites, that is Pad A and Pad B of Launch Complex 1 located in Maitra, New Zealand, and another Launch Complex 2 at Mid-Atlantic Regional Spaceport within the NASA Wallops flight facility in Virginia. Now speaking of stats, they got 26 orbital launches from Pad A of Launch Complex 1 and 19 orbital launches from Pad B of Launch Complex 1, including one of today's mission launch. To date, there have been 4 orbital launches from Launch Complex 2 in Virginia, and to sum up, they got 45 orbital launches from Launch Complex 1 here in Maitra, New Zealand, including today's launch. Moving on to this year's orbital launches, including today's one. Now here we are having a pie chart. The United States is dominating with 68 orbital launches, launch comprising a substantial 61.8% of the global total. Just a few moments ago, we did had a SpaceX Starlink Group 8-5 mission launch from Cape Canaveral Space Force Station. Before that, we had another Starlink mission, that was Starlink Group 6-64 mission back on May 31st. And speaking of Rocket Lab's previous mission, that was on 25th May, we had Rocket Lab's 48th Electron launch of NASA's PREFIRE CubeSats on its Ready, Aim and PREFIRE mission. And today is the next one, which we are witnessing, PREFIRE and ICE mission. While China follows closely behind, accounting for 24.5% with 27 launches, Russia maintains a steady pace with 8 launches, making 7.3% of the pie. With the recent Soyuz 2.1A launch of ISS Progress 88 or Progress MS-27 ISS cargo resupply mission on May 30th from Baikonur Cosmodrome. While Japan has 3 launches so far, making 2.7% of the pie, both India and Iran have entered the fray with 2 launches each, making 1.8% of the pie respectively. It is clear that the United States and China are undeniably dominating the space race this year. So now let's have a look into this pie chart we are having, showing 2024 orbital launches by rocket variations, including today's launch. First of all, let's speak about Electron, as this is a Rocket Lab's mission only. The yellow slice of the pie showing the Rocket Lab's Electron with 7 launches, making 6.3% of the pie, including today's launch. Then the big green slice of the pie, that's the Falcon 9 rocket, a real heavy hitter this year, having biggest share of the pie with 58 launches so far, making up more than half of the whole pie at 52.3% and leading. Next up, we got this pink slice labeled Others, which is a mix of different rockets, including Delta IV Heavy, Vulcan Centaur, Starship, ISRO's GSLV Mark II, PSLV DL, Japan's H3 and H2A, then Iran's Simorgh and Kayam 100, Russia's Angara A5, China's Gravity 1 and others. These names are not exhaustive, and I'm not taking the names of each individual launches, but they got 31 launches in total, which is 27.9% of the pie, which is quite impressive. Also, we have Soyuz 2 rockets with 7 launches so far this year, which is 6.3% of the pie. Last but not least, we got China's CZ-2D and CZ-2C rockets. Also, you can say them Long March 2D and Long March 2C. So the CZ-2D or Long March 2D has 5 launches, making 4.5% of the pie, and the CZ-2C, that is the Long March 2C, has 3 launches with 2.7% of the pie. Although smaller slices of the pie, but every launch counts. Now, as we await the payload separation, let's hear some music from My end, not from Rocket Lab's end.
the NASA PREFIRE climate change mission. Earlier today, our 49th Electron rocket lifted off from Rocket Lab Launch Complex 1 in New Zealand with its NASA satellite on board for a clean ascent through the usual launch milestones, including max Q, first stage engine shutdown, stage separation, and second stage engine start. After a nominal ascent with the second stage to the mission's target perigee of over 200 kilometres, the kick stage was separated and has just completed its first half pass of Earth. We're now approaching the startup of the kick stage's Curie engine to reposition the stage to a circular orbit. The full duration of the engine burn should last for just under a minute, so let's listen into mission control for confirmation for that Curie engine startup.
We are now at the final moments of the mission before the kick stage deploys the NASA satellite to space. Just few minutes from now, the kick stage will reach its 525 kilometers apogee above Earth, and the trajectory it will be delivered to is an elliptical orbit, which means that the kick stage and its satellite will be moving in an oval shape around Earth instead of a circular one. But in some moments, only the kick stage will lit up its Curie engine to place the kick stage and NASA's payload.
Curie ignition confirmed.
And we got the confirmation of the Curie engine
startup confirmed there by mission control. That will mean the kick stage is now out of its initial elliptical orbit and onto its 525 kilometre circular path ahead of the payload deployment of the NASA PREFIRE satellite. The kick station's propulsion system includes both our own Curie engine and 6 cold gas reaction control thrusters that enable the stage to perform orbit maneuvering and positioning like it is now, plane changes, and also orbit lowering burns for when we want to speed up the kick stage's timeline in space. Now, Curie is tiny compared to the Rutherford engine, but like the Rutherford, it is also a 3D printed engine that's integrated with lightweight carbon composite propellant tanks. We also heard over mission control there that we have had the successful shutdown of the kick stage's Curie engine, and that means we are now only moments away from payload deployment for NASA's PREFIRE satellite, set to be delivered to its 525 kilometre target orbit to begin its mission to collect data.
Now this course correction engine burn will, as you heard, that lasted for just under a minute, and then will come to that point when the engine is due to shut down, which occurred just a few moments before. Now, just for a reminder, the second PREFIRE satellite will be deployed to the same 525 kilometer circular Earth orbit on a similar but different trajectory to the first satellite, so that both will crisscross each other every few hours near the poles.
Only one more to go to reach Electron's 50th launch milestone, and we'll have details about our next mission available in the coming days, so keep an eye out on our social media channels and our website for the latest. But until then, thank you so much for joining us for today's launch. This is Rocket Lab Mission Control signing off.
And we did had a successful deployment of NASA's PREFIRE second satellite launch. Now today's launch marked 49th overall launch of an orbital class rocket, that's Rocket Lab's Electron. With that, we will wrap up our coverage for now. Be sure to check out the social media for any upcoming updates from Rocket Lab. We want to thank all of you joining us with today's launch, and we hope you all will enjoy the week ahead. Hope you enjoyed the stream. Once again, thanks for joining us, showing your such patience, love and understanding, staying till the end. and we are glad to have you all here with us. This is AstroYonder Live and me, Dipta, signing off for now, and we will see you next time.